Hello everyone. So in this video I am going to do another example with mesh analysis, very similar to the one we did in the last video, but instead of the voltage sources that we had, I'm going to switch them out for current sources. And you will find that some interesting things happen, and it modifies a little bit some of the steps that we need to take when doing mesh analysis. So let's go ahead and jump right into our example. So it's very similar, the exact same circuit, but with voltage sources replaced by current sources. Call this IS1. So R3, R2, R1. Call this IS2. And then we have R5. And R4. So let's go through the whole mesh analysis process again. So one is to go ahead and identify your meshes. So I identified this as mesh 1. This was mesh 2, and or actually no, I think that was, I defined that as mesh 3, and then mesh 2 over here. And it really doesn't matter what you call them. Just basically identify your meshes. So so we did that. We labeled, or actually I should say, I'll just say identified. And then 2, define mesh currents. Okay, so I think I'll keep the same orientation as, or the same labels as I did previously. So going clockwise for each one. This is I1. This is I3. And this is, oops, and this is I2. So we define our mesh currents, and then our step 3 is to apply KVL to each mesh. Now, before we do that, I want to point out something. We can go ahead and do that, right? We can apply KVL to each mesh, but one thing you'll notice though is that we run into these current sources, and we don't really know the voltage. We don't know the voltage across them. And then on the next step, when we have to apply Ohm's law, there's not really any, we can't use Ohm's law to express the voltage across this source in terms of our mesh currents. So we kind of run into a bit of a problem when we're doing mesh analysis and there are these current sources in our meshes. So I'm going to add a caveat to this rule here, and it's this. If you can't, because of a current source, then apply KVL across meshes. So some would even refer to taking a KVL across different meshes as like a super mesh, but I prefer just to say we're going to take a loop that doesn't that includes multiple meshes and that doesn't um, run into a current source. So if you think about it, so we've defined our meshes here, and we're not going to apply, according to that caveat in the rule there, we're not going to apply KVL here because there's a current source there. So, nope. Now let's ask whether we can apply KVL in this mesh. Nope, we've got the current source. KVL in this mesh. Nope, we've got the current source there. So instead, what we have to do, we have to think about, all right, maybe I could do a loop. Where's a loop that I could do, KVL loop, that doesn't include the current source? And it's going to be this loop here. You go all the way around here, you can basically do a KVL loop without encountering the current source. So let's go ahead and do that. So we're going to go basically all around here. What sometimes people term a super mesh. So I'll just call this KVL loop. Okay, so let's do it. All right, so, oh, and let's go ahead and label our voltages here. Let's say this is plus or minus V4, and again, I could have put the plus on top. I put it on bottom, doesn't matter. It'll work out in our math. Then I'll label this as plus or minus V2, voltage across R2, and then plus or minus V3, the voltage across R3, and then plus and minus V5, the voltage across R5. And again, I just arbitrarily assigned an orientation for that. It'll all work out in the end with the math. So let's do our KVL loop. Ready? So let's start going clockwise. What do we hit first? We hit the plus sign. So plus V4. So V4. So V4 plus, now we hit a plus sign here, so plus V2. Then we continue and we hit a plus sign here, plus V3. And then we continue and then we hit another plus sign there, plus V5. That's all equal to 0. And I want you to notice that there's no other KVL loops that we can do that don't involve crossing the voltage across a current source. So that is the one KVL equation that we have. So you might then ask, okay, one equation, but we have three unknowns. We have three mesh currents we're wanting to solve for, I1, I2, and I3. So we need to have two other equations. So that's the next step if you have these current sources. Next step is express the current, express the source. You know what, actually, I think it makes more sense to introduce that at the end. So let me first let's actually finish, let's complete this equation here because we still haven't applied Ohm's law to it. So back up a bit. And so step 4, just like the previous example we did in the other video, step 4 is going to be apply Ohm's law to each KVL equation. So essentially, when we want to express all these voltages in terms of the mesh currents. So we have V4 is equal to the current should be equal to the current through the resistor times its resistance. And since it's flowing, since I1 is going into the plus sign, it'll be positive. So it'll be R4 times I1. R4 times I1. Then let's do R1 here. Trying to do the easy ones first here. So V1 is equal to R1 times oh, you know what? Actually, so we don't have V1 is not in our KVL loop actually, so we don't need to express it. We don't need to plug it in. So instead, let's just take let's do V5. So V5 is equal to I2 times R5, or I5 times I2. Okay, so we have that voltage now. So now, what about V2 and V3? So V2 is going to be equal to the current going in this direction through R2 times its resistance. That current is I1 minus I3. I1 minus R3. And then V3, in a similar manner, is going to be equal to the current through the resistor times R3. The current through the resistor in this direction, from plus to minus, is equal to I2 minus I3. So I2 minus I3. So that gives you V3. So then what you can do is you can plug all these values in so that you have one equation with all of these in terms of all these mesh currents. So then the other question is, okay, like I mentioned previously, you have one equation, but you have three unknowns, three mesh currents. So here's the last step that you have to do if you have current sources. Express the current source values in terms of your mesh currents. So think about this. If you have a current here, IS2, flowing here, the current IS2 is going to be equal to, flowing from here to here, it's going to be equal to I2 minus I1. So IS2 is equal to I2 minus I1. And then IS1, current of your other source, well, there's no other mesh currents, so it's actually just going to be equal to I3. I3. So now you can see how we have three equations, three unknowns. You can basically simplify these equations, put them in a matrix, and solve for all of your mesh currents. And then that can allow you to solve for all the voltages as well. So that gives you just a different idea of how to solve a circuit with mesh analysis when you have current sources. So I hope that was helpful, and I will see you in the next video. Hello everybody, thanks for watching. If you found this content helpful, would you please consider liking and subscribing to the channel? That will help other people find it. And if you won't do it for me, will you do it for my cat, Muon? Named after my favorite subatomic particle, by the way. So, she will be very, very upset if you do not like and subscribe. So please, don't disappoint. How could you say no to this cuteness?